that the event is impossible. So again, in order to calculate a probability, it's equal to the number of favorable options divided by the number of total possible options. So before we divulge into probability, we have to understand certain definitions. So the first one is outcomes. It's a particular result of any random process. So it's the results you get from calculating a certain probability, whether they ask you to find the intersection, the union, or they ask you to find maybe a joint probability or a marginal probability. The outcome is your result. It's what you get from working out the information that you are given.
You know, my corridor, honey. Where were you? You wasn't in here.
All right. Next, we're going to be looking at the sample space, which is normally represented by S. This is a set of possible outcomes. So like if they ask you, this is normally a set of all possible outcomes. So it's normally what they're asking you to find that is represented by S. Next, the event is a list of all favorable outcomes. So if you have a sample set of, say, gender, maybe male or male and female, and you want to know how many of the persons are male, the probability of male, that will be the event that you're looking for. While your sample space would be male and female, because that's your target audience. Next, we have complements. So a complement usually denoted by AC or A asterisk is everything that is not in the event of interest. So if, as I said, you have a sample of male and female, and you wanted to know everyone that is not female, you know that will be everyone that's male. So the probability of not being a female will be A asterisk, would mean that you are a male. We have intersection, which is normally represented by an inverse U. So it represents all elements that belong to both the events of interest. So the example that I've been using is male and female. You can't really be a male and female at the same time. Well, you can. But we normally use intersection when we're talking about joint occurrence. We're talking about happening at the same time. They're simultaneous, or if you see anything about both, or if the question asks you about and, you know that you're dealing with an intersection. So again, an intersection is an inverse U. It represents all elements that belongs to both the events of interest. So if the question asks you to find and a joint occurrence happening at the same time, something that's simultaneous or both, you know you're dealing with an intersection. A union now is a U, the symbol is U. It represents all the elements that belongs to all the events of interest. So if they ask you for, like, if the question asks you for or either or at least, it is speaking about a union. Yeah, it's speaking about a union. And yeah. All right, so if something is a mutually exclusive event, if there is no intersection, it means that the two events cannot occur together at the same time. So your intersection, so in this case, the probability that A and B have something in common is equal to 0. Now we're going to be looking at independent events. So independent events is if the occurrence of one does not affect the occurrence of the other. So a war in Pakistan will not affect us going to school in Jamaica. So the two events are independent of each other. And in order to calculate independent events, as I said, it's normally denoted by probability that A is intersected by B, which is equal to the probability of A times the probability of B. Independent events occur in the case where one does not affect the other. So they're independent of each other. Now we're going to be looking at laws of total probability. All right, 1 second. All right, so you guys are asking me to go over complements. So as I say, a complement is denoted by AC or A asterisk, which is everything that is not in the event of interest. So as I was saying before, if I had two, if my sample space had male and female, so we're dealing with gender, so either a male or a female, and they asked me what's the probability of not being a female. So the complement of not being a female will be that you're male. So that's what complement is saying. Complement is just saying that everything that is not a part of the event of interest. So our event of interest is that you are not a female. So if you're not a female, you're going to be a male. So that's what a complement is. You guys okay with that? Alright, so basically the law of total probability states that the probability of A is equal to the probability of A intersect B plus the probability of A intersect B complement. Remember that the probability of B complement. Remember that the probability of B complement will always be what is not a part of B. So what wouldn't be a part of B would be A minus its intersection or even the universal set. Then De Morgan's law states that the probability of A intersect B all complements is equal to the probability of A complement intersect B complement. Guys, the notation in this is wrong. It should be the probability of A union B complement is equal to the probability of A complement intersect B complement. right, now we're going to be looking at the different types of probabilities. So we have three types of probabilities where we have marginal probabilities, joint probabilities, and conditional probabilities. So the first one we're going to look at is marginal probability. So marginal probability has to do with how often one variable occurs. So if they say that only one variable is mentioned or something like that, they're dealing with marginal probability. And it's calculated by the outside total divided by the total. Next, we have joint probability. So with joint probability, they're asking us, it has to do with how often that the combination of two variables occurs. So if they ask you about and together both, we're dealing with joint probability, and joint probability usually incorporates an intersection because it has to do with both and together. So joint probability is calculated by the inside count divided by the total. Then we have conditional probabilities. So conditional probability is normally assigned a fixed value for one variable and looks at the proportional or the percentage of the other variable under that condition. It's calculated using the inside count divided by the outside count. So conditional probability involves both variables, but narrows the table down by one of them ahead of time. So what this is saying is that what is the probability that A given B? So what it's saying is that the only way A can happen is if B already happened. That's what the statement. All right, Anna, what's your question? Anna? Do you have a question? Guys, if you have a question, you can always raise your hand and I will stop. All right, so what the conditional probability is saying, what's probability of A given B? So what is the probability of A happening given that B already occurred? It's equal to the probability of A intersect B divided by the probability of B. So whatever comes after this is your given sign. So it's saying that what's the probability of A given B? So the conditional is saying what's probability of A happening given that B already occurred is equal to the probability of A intersect B divided by the probability of B. So whatever comes after this sign is normally in your denominator and your numerator is represented by a intersection. So we're going to do a question based on the three different probabilities. So it says that the following is a two-way table showing the results for a sample of undergraduate students. So this is the part where you guys